Hope you guys enjoyed the Thanksgiving break, and of course, if you do not celebrate Thanksgiving, hope you guys just had a good week overall. I ended up going home and hanging out with friends and family, which is why I was not able to upload last week. So this week, we're going to be starting off with the 70th LeetCode problem, climbing stairs. Now, I was given a version of this problem for my Goldman Sachs interview, which of course I did end up doing well in. So I think that this is a very key problem to understand if you want to get into top tech companies. So let's dive right in by reading the problem statement. Climbing stairs. So you're climbing a staircase. It takes n steps to reach the top. Each time you climb, you can either take 1 or 2 steps. How many distinct ways can you climb to the top? And of course, we're given 2 examples here. One example is if the input is 2, which means that there's 2 stairs, there's 2 possible ways to climb to the top, taking 1 step and 1 step, or taking 2 steps at once. And of course, if the input is 3, which means 3 steps, there are 3 possible ways to climb to the top. Cool, now that we've read the problem statement, let's dive into the algorithm. So let's try to understand this problem and come up with an algorithm. Here's what we are given. So we can take 1 or 2 steps at a time on the stairwell, and we're given a few examples. Now let's see what we get with 4 steps. So we can just go 1 step at a time, or we can do 1 step, then 2, or we can do 1, 2, 1, or 2, 1, 1, or we can also do 2, 2. So there are 5 possible ways to travel up 4 steps if we're going 1 or 2 steps at a time. Let's try to understand this pattern here. And if I draw out these numbers, it might be a little bit more clear what's going on. So in the first step, we only have 1 way. In the second step, we have 2. If there's 3 steps, we have 3. If there's 4 steps, we have 5. And I hope you guys can see a little bit of a pattern here, and that pattern is actually reminiscent of the Fibonacci numbers. We have these 2 base cases, 1 and 2. To understand how many possible ways it is to climb 3 steps, we just have to add the previous 2 steps. 1 plus 2 is 3. 2 plus 3 is going to result in 5. Now, if you want to see if there are 5 steps, how many possible ways, then we just have to add 5 plus 3, and we will get 8. Cool. So just by drawing out these values, we were able to realize that this is a Fibonacci series. And hopefully you have come across this somewhere in your computer science degree, and it's not totally new to you, so you're not caught off guard. So now let's move to the actual approach that we can use to solve this problem. So I'm going to be doing the bottom-up approach to solve this problem. What we're going to say is we're going to be given a base case. So the base case is if there's only 1 step or if there's 2 steps. So if there's 1 step, there's 1 possible way. We already know that. If there's 2 steps, there's 2 possible ways. And what we can do to get n possible steps is just iterate in a for loop from 0 through n. And of course, we have our base cases. So all we have to do is say that n's value is equal to n minus 1 plus n minus 2, or the value of n minus 1 and the value of n minus 2. So we can just store a simple hash map, although we don't even need that. We only need like the 2 previous variables. But for simplicity's sake, I just use a hash map anyway. And we can easily add these values to a hash map. We take the index of the value, which is, in this case, it is 0. And we're going to say that is equal to 1, and the index of 2, which is 1, is equal to 2, and we want to just keep adding these values into the hash map as we iterate through. So once we get here, we're just going to sum these 2 values, and we're going to get 3, and we're going to add that to the hash map. So the second value, the second index in the hash map, the key, is going to be 2, and the value is going to be 3. Now we're going to be here, and all we got to do is add these 2 values, 5. Now this represents index 3, and we can just say 3 is equal to 5. Now we just have to add these once again. We get 8. Now this is the 4th index, and we can go on and continue to add values to the hash map until we reach our nth value, at which point we can just quickly return the answer. Cool. Now that we understand the algorithm, let's jump into the big O time and space complexity. In terms of time complexity, we know that if we are to find how many possible ways it is to take n steps, we have to iterate in a for loop from 0 through n. So in this case, the time complexity is just going to be O of n. And in my solution, I end up using a hash map, even though it's not really necessary. So the space complexity is going to be O of n. Now, if you want to use just the 2 previous values, you can do that. You don't really need a hash map. And at that point, you'll be running into a constant time or constant space algorithm. Now that we understand the algorithm and the big O time complexity and space complexity, we can jump into the code. We have 3 base cases. The first one is if n is equal to 0, then we just return 0. If it's equal to 1, we return 1. And of course, if it's equal to 2, then we return 2. Afterwards, we create this hash map. Now just remember that this hash map is not actually necessary. I just do it for simplicity's sake. You can just store the 2 previous values and iterate to get the sum of the current value, which will give you the constant space algorithm. Anyways, so we go through the range from 3 to n plus 1. Note, I go to n plus 1 because the range function is inclusive on the left side, but non-inclusive on the right side. So we have to go 1 step forward to get the value of n. So all we do is update the hash map with the current value. And of course, the current value is going to be the value which is 1 step before plus the value which is 2 steps before. And that is coming straight from the algorithm that we discussed previously. And at the end, all we got to do is return the value that is stored in the dictionary at the nth position. Let's just submit and see what happens. It is fine. As always, it works. There were times that this was faster, such as the time that I got 16 milliseconds, which I think was faster than like 75% of all solutions. Anyway, doesn't really matter. These are small optimizations to keep in mind. Hope you guys enjoyed. If you did, leave a like and subscribe for more in the future. I post weekly on Mondays. Thanks for watching, and I'll catch you guys next time.